everybody. This lesson is with quadratic equations and being able to determine from the graph where the roots and the intercepts of that quadratic equation are. So graphs of quadratic equations, they're going to be parabolas. So this here shows our parabola shape. We've got two clear sides of our graph, and often it will cross our x-axis in two spots. It may cross in one spot, or it might not cross our x-axis at all, and we'll look at some examples of that. And a parabola has what's called a vertex, or a turning point in our graph. And to find that vertex, you would take your two x-intercepts and find the average of those two, because you want the exact middle point. So you'd add up your two x coordinates and divide it in half, and then plug that x value into your equation to find the y. And we'll go through some more examples of that in a bit. And like I mentioned, your graph can have two x-intercepts, like this graph does. It could have one x-intercept where that vertex is actually on the graph of that line, or it could have no x-intercepts where the graph might curve upwards like this and never actually cross our x-axis. And to find what those vertex or what those values are, you can use the quadratic formula. So just a couple of examples. Our parabolas can also open upwards or downwards. So here's some examples of up, and two examples of where our parabola opens up downwards. And our vertex could be above. So note here, our vertex is above. It could also be the case where it's below the x-axis. If this same graph was flipped over, it might not ever cross our x-axis. It might be down here. If it's on our x-axis, right here, showing on our x-axis, and then here going through 2 points. And like I mentioned, two x-intercepts means that your graph is going all the way through our x-axis and it's crossing our x-axis in two specific points. So here's an example of what that would look like if our graph opened upwards. Here's an example of what it could look like if our graph opens downwards. But you can clearly see if there's two x-intercepts, if our graph is crossing this x-axis at two specific points. And it's helpful to remember our quadratic equation setup, where it's ax squared plus bx plus c. So you can clearly tell what a, b, and c are. Here's an example where there's one x-intercept. If there's one x-intercept, then that vertex point is the point that's on our x-axis. So right here, we can see that this parabola has a vertex on this coordinate 2, 0, and then our graph opens up. There's only one x-intercept for this example. This one here, vertex is on the x-axis, but this one actually opens downward, and it has one x-intercept. And this vertex is right here at -2, 0. And it could also be the place where there's no x-intercept. So this would be where the vertex is actually above the x-axis and our graph would open upwards. Or there might be no x-intercepts where the vertex is below the x-axis and our graph opens downwards. So just the different types of parabolas that you might see. And specifically, to know if your graph opens upwards or downwards, you want to look at that value of a. If a is positive, then the graph opens upwards. If a is negative, then the graph will open downwards. So in these examples here, for question number 1, a is where this 5 is, because we want to use our equation ax squared plus bx plus c equals 0. So a is positive here, so this graph would open upwards like this. Question 2, negative. This graph would open downwards. And number 3, also negative where our a is, so this one would open downwards for that graph. So remember that. If a is positive, it opens up. If a is negative, it opens down. Now thinking about that vertex. So remember, our vertex can lie below the x-axis, on the x-axis, or above the x-axis. And the vertex is on the x-axis when there's only one x-intercept. So think about this. My graph has two intercepts, and it opens upward. Would my graph be on, above, or below the x-axis? So just think, if I have two intercepts, that means it's crossing somewhere on my graph. I don't know where exactly, but I know it's crossing in two spots. So my graph, if it opens upward, my graph would have to go through these 2 points and open upward. So you would say my vertex is below the x-axis because it would have to be down here. So this one would be an example of where it's below. So it definitely helps to visualize this by drawing a picture. Another example, my graph has one intercept. So somewhere on this x-axis it's crossing at one spot. So let's just say it's there. And my graph opens downward. So my graph would have to go through that point like that. Is the vertex on, above, or below? This one is on, and you would know that without graphing because there's only one x-intercept. Anytime there's only one x-intercept, there's only one vertex, and that vertex is on, well, there's always only one vertex, but that vertex is on that x-axis. So if there's one intercept, the vertex is on that x-axis. And my graph isn't super accurate, but you get the idea. Another example of this, my graph has 0 intercepts. So this means it's not crossing my x-axis at all. And it opens down or upward. So if you think of it, my graph has to go like this. Okay, and it opens upwards. Is it on the vertex, above the vertex, or below? If it's not crossing anywhere, it would have to be above because it opens upwards. So think if I move this around, if it's opening above but it can never actually cross that x-axis, notice my vertex has to be above that x-axis because it never actually crosses. Once it crosses, once this x-axis crosses, notice now we've got x-intercepts. So it's crossing that x-axis, we get intercepts. So if we don't want it to cross that x-axis for intercepts, that vertex has to be above that x-axis. So we've talked about having the x-intercepts, either 1, 2, or 0. But now the way to, if you're given the equation to determine the number of x-intercepts, we've actually already done this before when we calculated out the discriminant. So the discriminant is this part of our quadratic equation, b squared minus 4ac, and it's going to determine the number of roots, or as we call them, x-intercepts. And this should be familiar. If it's going to equal a positive number, and you calculate this out, then there's 2 x-intercepts. If it equals 0, then there's 1 x-intercept. And if it equals a negative, then there's no x-intercepts. So if we actually use our discriminant to calculate this out, so this one, a, b, and c. So b squared, so our negative 3 squared minus 4 times a, my a is 5, so 4 times 5 times c, my c is 4. Whoops. So negative 3 squared, so 3 times 3 is, or negative 3 times 3 is 9, minus 4 times 5 is 20, 20 times 4 is 80. Did I miss a negative in here? No. So 9 minus 80, this one is going to come out to be a negative number. 9 minus 80 is a negative 71. So since this is negative, there's no x-intercepts. So we would say no intercepts. If we try it with a second one, so b squared minus 4ac, my b is a minus 8. So minus 8 squared minus 4 times a, so negative 3 times 13. So 64 here. And then negative 4 times a negative 3. We've got a positive. And then 12 times 13. We end up with 156. 156 plus 64, we have 220. So 220, it's positive. It's a positive number. Then I'm going to have 2 intercepts. So I would list that there are 2 intercepts. So use the discriminant to calculate the number of x-intercepts. Not what they are, but the number of them. So if your discriminant calculates out to be a positive number, you've got 2 x-intercepts. If you calculate it out and it equals 0, then there's 1 x-intercept and it's on that x-axis. And if it's negative, then you would have no x-intercepts. So the discriminant is used to calculate the number of roots. The quadratic formula is going to be used to calculate what those roots are. So you're solving to find those roots. So again, discriminant is going to tell you the number of roots. The quadratic formula will tell you what those roots are. So looking at an example for calculating, well, we've used the quadratic formula. You'll plug in your A and your B and your C into your quadratic formula to find what those actual numbers are. So calculate it out using that formula. And then specifically to find that vertex point, once you've got your 2 x-intercepts. So in this example, we've used the quadratic formula. We found our 2 intercepts, 4, 0, and 2, 0. To find that vertex coordinate, you add your x-coordinates, so 4 and 2, to get 6, and divide it in half, because you want the exact middle of those 2 x-coordinates. So we found that to be 3. Once you know that it's crossing it, or that the vertex is 3, to find what the y-coordinate is, plug it back into your equation. So back into this equation. So 3 squared and then minus 6 times 3. So here we've got it plugged in for 3. So 3 squared is 9 minus 18 plus 8. Simplifying that, we get y to equal negative 1. So our vertex coordinate, if you were to graph it, is 3, negative 1. And if you're using your quadratic formula to find this, I know I jumped to what this is, but for your quadratic formula, you just plug in those values and you're going to end up with, when I would solve this, I would end up with x equals 4 and x equals 2. Notice how we wrote them as coordinates. We wrote them as our x value is 4, and since it's an intercept, it's on that y-axis, the y-coordinate is 0. This one over here, you solve it, you end up with x equals 2. Our x-intercept is at 2. The y value on our x-intercept is 0. And one last example, combining it all together. So looking at this equation, I know my graph is going to open upwards because A is positive. So I'm just going to jot this down as a note. It opens upwards. The number of intercepts, calculating out the discriminant. So b squared minus 4ac, we've got negative 6 squared minus 4 times 1 times 8. So 36 minus 32, we get 4. So it's positive. I know I've got 2 x-intercepts. So looking at this, we've got our discriminant calculated out, a equals 4. Plugging it into our quadratic formula, multiplying it out, we found x to equal 4 and x to equal 2. So that's the ordered pair 2, 4 and 4, 0. And then finding that vertex point, add the 2 x values and divide in half. We get 3. Plugging it into our original equation to find y, we get negative 1. Graphing those 3 points are 2 intercepts, 2, 0 and 4, 0, and 3, negative 1. We get our vertex, and there is the graph of this parabola.